All right, let's begin by talking about slope, and then we're going to talk about the forms of the equations of lines for slope, with slope, rather. So the slope is the vertical change over the horizontal change. It's a way to quantify the tilt of a line, really. And the way we do that is with rise over run. Or if you know 2 points, you can do this formula. Okay? So what you want to do when you have a graph is locate good points, points that cross the grid perfectly, like these two, and then all you do is you count. So I always go up and down first, and I start on the left, so this would be down 1, and this would be plus 2. So the slope, m, is rise over run, which is negative 1 over 2. Okay? This is a kind of a special case. This is the line x equals negative 2 because all the points on this line all have an x value of negative 2. And because it's vertical, the slope doesn't exist. And there's a few reasons why the slope doesn't exist. One of which is it doesn't run at all. Like if you just look at rise over run, the run is 0. So you can't divide by 0. It just doesn't exist. So slope doesn't really quite apply to this line. You could say it has an infinite slope as well. Whereas any other line like this, you can simply take 2 points, and it does have a rise and a run. And I'll give another exception here. We go up first and then go to the right 3. So the slope, remember we're doing the rise first over 3. Okay. Now you can also have lines that are horizontal, and those have a slope of 0. Because if you were walking across it or driving across it, you don't have any incline at all, so the slope is 0. Find the slope between 2 points. Well, start by writing all of this. We want to copy down our formula. And you also want to, I really encourage you to do this, is write down this little template for yourself so that when you go and look at y2, which is 6, you know exactly where to put it, and there's a spot already for you. And then y1 looks like it's 2. X2 is 7. And x1 is minus 5. Okay. So it turns out that this should be 1/3. Okay. So for this one, I'm going to treat it the exact same way. I'm going to just write down my formula. I'm going to write it down with parentheses because I'm going to plug stuff in. And then I'm going to go one by one and say y2 is 5, y1 is 5, x2 is 4, and x1 is minus 3. It turns out we get 0 over 7. And if I had 0 pieces of candy and I divided it among 7 students, how much candy would each student get? The answer is 0. If I had 0 to give, they're getting nothing. So this division is 0. So if you have 0 on the top and a number other than 0 on the bottom, it's 0. 0 over 0 is actually a big question mark. It can be a number sometimes it's not. It depends on the context. It could take on the form of any number. And then if you had 10 divided by 0, like we did up at the second graph above, we just say that doesn't exist. Okay? So those are the 0 cases. So equations of lines. We have 2 that we're going to focus on. mx plus b, and we also have point slope form. So this one, the key features are the slope m and the y-intercept. The y-intercept is where it crosses the y-axis. Here we have the slope and a point. Okay, so when we're asked to graph, one, you can use a graphing calculator. However, for this test, I want to test to see if you guys can do it by hand, because it is, it does help you in understanding later stuff in math by knowing how to do this stuff on paper and have that understanding. The calculator will do too much for you, and you'll lack some of the understanding. So depending on what you have, what form you're in, if you're in this form, your first step is going to be to plot B. And if you're in the other form, point slope form, you're going to plot the point itself. So for step 1, you plot the first point, and step 2, you plot the second point. Because you only need 2 points to make a line. And we're going to do that by using the slope. Okay? So let me show you. So for this one, we're going to I personally like to write this underneath, and I suggest that you do that too. So then we can clearly see that m should be 3 and b should be minus 1. And all you do is you go to minus 1, and that checks off the b, and then you have to move up 3 and over 1. And that uses the slope to get a second point. And as long as you try your best and just connect the dots, I'm not asking for a beautiful picture, I'm asking just kind of for a sketch, that'll do it. So it's not bad. It's really not bad. And even if you have a fraction, it's still good. So m this time is minus 1/4, and b is 2. So if you go to 2 and you go down 1 over 4, there's your line. It has a negative slope, and that's why it tilts down. Now, the next two are in point slope form, and you can do one of two things. And I'll do one question one way, the other question the other way. For this, if you like 1 and 2, and that makes sense to you, what you might want to try and do is solve for y. So you distribute first, and then you subtract, and get an equation that's in y equals mx plus b form. See that? Perfect, great. That means the slope is 2, and it means b is minus 5. So if I go to minus 5 and go up 2 over 1, I have my line. Perfect. Okay? So very viable, very fine. This is how I did it in high school, definitely. However, when you have fractions like this and you have to anticipate distributing this, which is a little awkward, right? It means we have to double the fraction, so it'd be like 4/3. And I don't want b to involve a fraction. I want to be a little bit more certain. So if you're up for something new, what you can do is write down the point slope form. Wow, it's really, I don't know what's up. Sorry, guys. And this time, we don't care what b is. We want to know what the point is. x1, y1. And if we look here, just at this part, what does y1 need to be so they match? 1. And if we look over here, what does x1 need to be so they match? It's not 2, it's actually minus 2. So what we can do is plot that point, and then remember the slope is always the number that is in this position right here, kind of right after the equal sign. And we can move down 2 and over 3. Then we have the line. Let me have it connected a little bit better because I want to show you something. So if you don't like that, you could still do it how we did 3, but you would get a fraction. And you can see that here, because this point right here is b. So, or the y value is b. See how it's in between the grid? So it's just not as nice of a picture to even plot that. We'd rather have 2 points that are like coordinates with whole numbers. Okay. And then as a reminder, x equals 3. What you could do is a line is a collection of points, and this equation is saying that x, which is this, is 3. You could just put a bunch of points that have an x value of 3, and the equation is this. Or I'm sorry, the graph is this. So this is vertical, and the slope does not exist. And then on the other hand, if you had this equation, you would just have a bunch of points. It's a line, so you would just have a bunch of points where y is minus 2. And if you connect the dots, it's horizontal. And the slope is 0. Okay? It's a fair slope. Like, that is fine. Like, you can be flat like that. All right. And then we got this chunk here left. So what is the equation of a line with a slope and a y-intercept? Well, we have a form, slope-intercept form, that does exactly that. We just have to plug in 4 and -7. What is the equation of a line through a point with a slope of 3? Well, this is a point. We call it x1, y1. And this is the slope. So point slope form is perfect here. And all you would need to do is replace the numbers. So this would be like that. And we do have a double negative there that makes a plus. And this. You don't need to simplify it though. It did not ask for a simplified equation or anything like that. So don't feel the need to change anything. Just plop the stuff in there and move on. You don't have to solve it for y. It doesn't ask you to do that. If you are given a equation like this, one thing I always look for is the y-intercept. And for this one, it looks like it's like hanging out halfway between. So I don't really trust that. Like, I don't know if that's exactly half or not. So I'm going to take a different route and maybe find the slope first, which is going to be y2 minus y1, x2 minus x1. So this is going to be my x1, y1. It doesn't matter which one you call 1 and 2, by the way. It'll work itself out. I just like to pick the leftmost one to be 1. So how does this work then? So let's put our parentheses, since I promised that we would do that every time. And y2 minus 1. y1, 4. x2, 3. x1 minus 3. So this ends up being minus 5 over 6. Let's do a quick double check and make sure that's right. Yep. Okay. Great. So to make an equation, we need the slope and we need the y-intercept. And we don't really have that because it's kind of like between. So we also can make a line if we know the slope and a point. So I'm going to use this to finish off the problem. I'm going to put the slope in there. And I'm going to leave room for a point, and I can pick whichever point I want. I'll just go ahead and pick the one that is already labeled with a 1. So this is going to end up being minus 3, and this is going to end up being 4. Okay? So remember, there's two forms. It's not just y equals mx plus b. There's this one too, and it's really handy. Oh, and then here, they're just kind of sprinkled in here. Remember, this is at 3. So all of these points, which all the points together make the line. That's it. Okay? So this is a vertical line. Okay? All right. What is the equation of a line through 2 points? Well, we would have to do the slope formula again. Unless you want to draw a picture and count the boxes. You could do that too, but that might take a while. Scoot this down a little bit so we can label our points. So y2 is 5, y1 is minus 1, x2 is 3, and x1 is minus 2. So this ends up being 6 over 5. We don't have any idea what b is, but we do know that we have a point and a slope. So why not use point-slope form? Okay. And simply just make 3 substitutions. The slope first. The x and the y stay in there. They give structure to the equation. But x1 and y1 are numbers. So for us, x1 was minus 2 and y1 was minus 1. Okay? And if you used the other point, you would have it would look different, but it would end up being the same thing. Okay. And then last question. I know it's a bit of a long video. Thanks for making it this far. What is an equation of a line through 2 points in slope-intercept form? So it's the same question, but they want it to be solved for y equals mx plus b. Okay, so what do we do to start? We need the equation of a line. So you need the slope for sure, and then you need a point. Or if we had b, that'd be cool. but we don't have b. So if we had b, this would be really a lot easier. So the slope, just give me a moment to write down my formula. And I will probably provide these on the board for you. I worry if I don't provide them that I'll get a bunch of blank answers, and I want you guys to at least attempt the problems. So this is going to be the second point. This is going to be the first point. Oops. So, I always mess that up. y2 is 6, y1 is -2, x2 is 3, x1 is 1. So m is 8/2, which is 4. So we would then, after finding that out, we have no idea what b is. It'd be really cool if we knew b, because then we would be basically done. But we got to plug m and the point back into here, which I am looking here and here. See how I plugged in those three things? And then normally we'd be done, but it's insisting that we have it in a different form. So what we have to do is end up distributing the 4 and subtracting 2. So we get this. This is the final answer because it's in the desired mx plus b form. Okay? A lot of notes here, but this is Algebra 1 stuff.